In this question, we've been given a list of data and we've been asked to calculate various statistics from there. So first we've been asked to find the median and the quartiles. Okay, so there are 12 values altogether and we know we can find the position of each of these quartiles. Q1's position, we're going to use n plus 1 divided by 4. In this case, n is 12, so 12 plus 1 divided by 4. That tells us to look in the 3.25th position. Okay, so that's in between the third and the fourth. The third is 47, the fourth is 49, we're looking for 48, right in the middle. The median position, that's going to be the 6.5th value. The 6.5th value, this is going to be in between the 6th and the 7th. The 6th is 52, the 7th value is 54, we're looking for 53. That's our median. And now the upper quartile is 3 times the position of the lower quartile. It's 3 times 12 plus 1 over 4. It's 3 times 3.25. It's the 9.75th position. In between the 9th and the 10th, it's 56 since they were both 56. We're then asked to calculate the mean and the standard deviation. You know already, I just want you to type these values into your calculator and go to the summary screen. There you'll see the sum of x, you'll see the n value, and you'll see the x bar value. You're allowed to write 50.5 as your final answer. I'm in a habit of showing the fraction, 606 over 12, 50.5. The same thing for the standard deviation. You're going to have it right there on your screen. It's going to be sigma with a little subscript x. I'm going to substitute it into the formula. I want to always remind myself of the formula. Sum of x squared over n minus the mean squared. So, substitute it into there. Eventually, we get an answer of 8.539. In part C, we're asked to check whether there are any outliers and to justify whether there's any outliers. So we're not just going to eyeball this or do it by inspection. We need a calculation to back up our claim. So let's use the quartiles. Firstly, the interquartile range is Q3 minus Q1. So that gives us an interquartile range of 8. And we know we can find outliers by doing Q1 minus 1.5 times the interquartile range and Q3 plus 1.5 times the interquartile range. So in this case, the lower quartile is 48, and if we subtract 1.5 times 8, that gets us 36. The upper quartile is 56, and if we add on 1.5 times 8, that gets us 68. So the outlier boundaries are 36 and 68. Any values beyond those are going to be outliers. Having a look through, I can see that 25 is smaller than 36, but there are no numbers bigger than 68. So 25 is an outlier. It's the only outlier that we have. Using quartiles is not the only way to identify outliers. We could have used x bar plus or minus 2 standard deviations. I'd always recommend that you make use of the values and the calculations you've already done. So if you'd only done the quartiles so far, that's what I'd expect you to be using. If you'd only calculated x bar and sigma, that's what you should be using. In this case, we had both, so we had a choice, but I went straight for the quartiles. If we had used x bar plus 2 standard deviations, or x bar minus 2 standard deviations, we would have got the same conclusion that 25 is the only outlier. In part E, we're asked to draw a suitably labeled box plot. Okay, so we're going to start by identifying the outlier, which is 25, and then we'll go for the lower quartile, 48, the median, 53, and the upper quartile, 56. So these three, they're going to make the box, and from there I'm just going to add on the upper whisker, which is going to be the maximum value, and for the lower whisker, I'm going to go for the smallest value within the outlier boundary, so 47. And here's the box plot we're expected to produce.